Hello dear students. Last class we discussed the selective hydrogenation in the preparation of the alkanes process, and today we will be continue the preparation of the alkanes by using the alkyl halides. So come to the topic here, preparation of the alkyl preparation of the alkanes from alkyl halides. Today topic we will be discuss the preparation of the alkanes from the alkyl halide. So preparation of the alkanes from the alkyl halide, how can you prepare here? So for preparation of the alkanes from the alkyl halide, we have to follow some different reactions we have to follow. Here the first one, preparation of the alkyl halide, preparation of the alkane from the alkyl halide, preparation of the alkane from the alkyl halide. So first one of the reaction is a Wurtz reaction. First reaction is Wurtz reaction. From the Wurtz reaction we can prepare the alkanes by using alkyl halide, and the second one is Frankland reaction. Second one is Frankland reaction, and the third one is fitting reaction. Third one is fitting reaction, and the fourth one is Wurtz fitting reaction. Fourth one is Wurtz fitting reaction, and the fifth one is Uluman synthesis. Fifth one is Uluman synthesis, and the sixth one is Core house synthesis. Sixth one is Core house synthesis. So by using these six reactions, we can prepare the alkanes from the alkyl halide. Once again, preparation of the alkanes from the alkyl halide, we can prepare the alkanes from the alkyl halide by using the different reactions. In that first one is Wurtz reaction, and the second one is Frankland reaction, third one is fitting, fourth one is Wurtz fitting, and the fifth one is Uluman synthesis, sixth one is Core house synthesis. By using these six reactions, we can prepare the alkanes. We can prepare from the alkyl halide. We can prepare the alkanes from the alkyl halide. So chalo, let we discuss the preparation of the alkane from the alkyl halide with the help of Wurtz reaction. So now, how can you prepare the alkanes with the help of Wurtz reaction? So first of all, what is Wurtz reaction and how can you prepare the alkane? Let us discuss here. So first one is a Wurtz reaction. So first one is what here? Wurtz reaction. So Wurtz reaction means alkyl halide. Alkyl halide is treatment with, alkyl halide is on treatment with sodium metal. Alkyl halide is treatment with the sodium metal in the presence of dry ether will be give the higher alkane with even number of carbon atoms. Once again, here alkyl halide on treatment with the sodium metal in the presence of dry ether. In the presence of dry ether will be get the higher alkanes with even number of carbon atom, and sodium halides will be get. So this reaction we call as a Wurtz reaction. So once again, what is the Wurtz reaction? Alkyl halides on treatment with the sodium in the presence of dry ether will be get the higher alkanes with even number of carbon atom, and will get the sodium halides. So in this process we can prepare the alkanes. So let us see the example, how can you prepare the alkanes here. So for example, I am taking methyl chloride I am taking. So 2 moles of alkyl halides and 2 moles of sodium I have to take for preparation of the alkane, because 2 alkyl groups we are taking, the 2 alkyl groups will be get from the 2 alkyl halide. So I am taking 2 moles of sodium with 2 moles of alkyl halide. With the 2 moles of alkyl halide I am taking in the presence of dry ether. In the presence of what? Dry ether. In the presence of dry ether I am taking. So here sodium and these 2 chlorine atom and the 2 atoms of sodium, 2 atoms of chlorine will be converted as a 2 moles of sodium chloride. and the remaining is what here? Here one of the methyl group is left over and here one of the methyl group is left over. The two methyl groups will be combined and forms a ethane. And forms what? Ethane. So this is the preparation of the alkane with the help of Wurtz reaction. With the help of what? Wurtz reaction we prepare the alkane. So another example I am taking. For example, if I am taking ethyl chloride. For example, I am taking the ethyl chloride with the help of 2 atoms of sodium and in the presence of dry ether. In the presence of dry ether. So same reaction. Again, sodium, here sodium react with 2 atoms of sodium react with 2 atoms of chlorine and will be converted as a sodium chloride. And this is converting as a 2 atoms of or 2 molecules of sodium chloride and the product is forming here C2H5 and this is the C2H5. 2 molecules of the C2H5 will be combined and the product is forming here. So the product is C2H5 and C2H5. So the product is what here? Butane will be get. So this is a higher alkane. It is a higher alkane with even number of carbon atoms and here also even number of carbon atom. So once again, Wurtz reaction means, so what is the Wurtz reaction here? Alkyl halides. Alkyl halides on treatment with sodium in the presence of dry ether as a solvent will be get the higher alkanes with even number of carbon atom. So here I am taking the methyl chloride, the product is alkane with even number of carbon atoms and here I am taking alkyl chloride, that means ethyl chloride, the product is forming butane, here also even number of carbon atoms. So mainly in the Wurtz reaction will be get the alkanes with the even number of carbon atom. So now this is what a Wurtz reaction. So this is a Wurtz reaction and one more reaction is there here we have to discuss. This is a crossed Wurtz reaction. That is what? Crossed Wurtz reaction. So what is crossed Wurtz reaction? So we discussed already Wurtz reaction. Then what is crossed Wurtz reaction? So once you observe here, Wurtz reaction nothing but 2 same alkyl halides I am taking. This is what? Methyl chloride. It is also methyl chloride. And this one is ethyl chloride. It is also ethyl chloride. 2 same alkyl halide. 2 same alkyl halide when it is react with sodium. At that time we call as a Wurtz reaction. Then crossed Wurtz reaction nothing but 2 different alkyl halides is reacting each other. 2 different alkyl halides is reacting. For example, I am taking methyl chloride. It is reacting with 2 atoms of sodium and 1 mole product is ethyl chloride. 1 mole product what I am taking? Ethyl chloride. Let us see, this is methyl chloride, it is ethyl chloride. 2 different alkyl halides are reacting with sodium metal in the presence of dry ether. In the presence of dry ether. At that time, the product is forming as a mixture. The product is forming what? Mixture is the product is formed. So what is the forming as a product? Mixture is forming as a product. Let us see, this is the methyl chloride, it is the ethyl chloride. So once this bond is break here, once this bond is break here, you can get methyl and you will get the ethyl. This methyl can be react with this ethyl. So at that time, the product is possible. The products are possible here. CH3, C2H5, this is one of the product. And here 2 atoms of or 2 molecules of methyl also can be react. At that time will be get the product ethane. At the same time 2 molecules of ethyl also can be react. At that time will be get the product C2H5, C2H5 also will get. So totally 3 types of product will be get. One is methyl react with ethyl will be formed methyl and ethyl as a product, and one more is 2 molecules of methyl can be react and one more is 2 molecules of ethyl can be react. So totally here 3 different product is forming. We can say that is a mixture. A mixture of the 3 different product is forming when 2 different alkyl halides are react. When 2 different alkyl halides are react with the sodium in the presence of dry ether, will be get the mixture of the 3 products. So once again finally, Wurtz reaction nothing but here what? Alkyl halides are reacting with the sodium in the presence of dry ether, will be get the higher alkanes with even number of carbon atoms. And the next one is crossed Wurtz reaction. 2 different alkyl halides. 2 different alkyl halides react with the sodium in the presence of dry ether, will be get the mixture of the three products that is called as a crossed Wurtz reaction. So this is one is Wurtz reaction and one more is crossed Wurtz reaction. So once you take the screenshot. So next one is here in this every reaction we are discussing in the presence of dry ether. In every reaction we are discussing what? In the presence of dry ether. Then what is the main function of dry ether? What is the main function of dry ether? In the first reaction also we discuss in the presence of dry ether. Second reaction also dry ether. In the crossed Wurtz reaction also we discuss about the dry ether. So why particularly dry ether? Why particularly dry ether we have to take? So is any particular reason is there? So to know that will be discussed once again that when I am taking the dry ether. So when I am taking the dry ether in the Wurtz reaction, the main reason to take the dry ether in the Wurtz reaction, dry ether is a inert solvent. Dry ether is behaving as an inert solvent. Due to the inert nature of the dry ether we are taking in this reaction. So that means whatever the alkyl halides, whatever the sodium we are taking, that reactants or those particular substances does not react with the dry ether because dry ether is a inert in nature. So this is the one of the reason. And the second reason to take the dry ether, so sodium. So we are taking the metal atom is a sodium. So sodium it is loses some number of electrons. Sodium it is loses the electrons, it is loses to participating in the reaction. To remove the electrons from the sodium, some amount of energy required. Generally that energy we call as a ionization energy. So this energy is provided when this sodium metal is solvated with the dry ether. Sodium metal when solvated with the dry ether, some amount of solvation energy produces. That energy responsible to remove the electron from the sodium. Because of that only sodium plus is participating in the reaction. So once again, what is the reasons to take the dry ether mean? Mainly one reason, dry ether is behaving as an inert solvent, and the next one is to remove the electron from the sodium, we need some amount of energy that is called ionization energy. That ionization energy it is takes or that ionization energy is produces in the reaction when sodium metal is reacting with the dry ether. Sodium metal is solvated with the dry ether, the amount of energy releases. So this is the reason to take the dry ether. So next one here, this reaction. So this Wurtz reaction generally, whatever the Wurtz reaction we are taking, this Wurtz reaction is two types is possible. One is a free radical mechanism. And the second one is a ionic mechanism. One is free radical mechanism and the second one is ionic mechanism. Once again, Wurtz reaction mechanism takes place by the two mechanisms or two methods. One is free radical mechanism and other one is ionic mechanism. So generally free radical mechanism is favorable. Compared to ionic mechanism. So let us discuss how the two types of mechanisms takes place in the Wurtz reaction. Let us discuss. First one is free radical mechanism. Free radical mechanism. In the free radical mechanism, how the alkyl halide is converted to alkanes we are going to discuss. The method is free radical mechanism. So let us see the free radical mechanism. We are taking the sodium metal and the sodium metal loses one electron and converted to sodium plus. Next one is alkyl halide we are taking. For example, if I take the ethyl chloride, free radical mechanism, so the bond is breaking equally. When the bond is breaks equally, will be get the CH3CH2 free radical plus chlorine free radical. Whatever the electron losing by the sodium, that electron is taken by the Cl free radical and the chlorine free radical converted to chloride ion. So chlorine free radical is converted to chloride ion. So now this sodium and this chloride will be converted to sodium chloride. Now in our reaction, I am taking the 2 moles of alkyl halide. In our reaction, we are taking the 2 moles of alkyl halide we are taking. When we are taking 1 mole of alkyl halide, 1 ethyl free radical we are getting. If I take the 2 moles of alkyl halide, 2 ethyl free radicals will be get. So the 2 ethyl free radical, if it is combined, CH3 and CH2 free radical plus CH2 CH3 free radical here. So these two free radical containing species, if it is combined, the product is forming as a butane. The product is forming as a butane. So this is we can treat as a major product. This is we can treat as a major product in the free radical mechanism. So once again, in the free radical mechanism, sodium loses 1 electron. At the same time, alkyl chloride, it is participating in the free radical mechanism, and the bond is break equally. We will get the chloride free radical and alkyl free radical. Whatever the electron losing by the sodium, that electron taken by the chloride free radical and converted to Cl minus. Now here when I am taking 1 mole of alkyl chloride or 1 mole of ethyl chloride, 1 ethyl free radical we are getting. Generally we are taking 2 moles of ethyl chloride or 2 moles of alkyl halide in the Wurtz reaction. When I am taking 2 moles of alkyl halide, 2 alkyl free radicals we are getting. First alkyl free radical, second alkyl free radical. So both are having electrons. When these free radicals are combined, will be get the butane. So this is a major product, and this we call as a association. This is what we call here association, and one more process also takes place in the free radical mechanism. So what is another process? For example, you see here, these are the 2 free radicals are there. For example, this is the first method, and the second process, for example, I am taking this free radical. It is CH3, CH2 free radical. This CH3, I am writing as a CH2H and CH2 free radical plus CH2 free radical and CH3. So this we are getting. Now again, this is participating in the bond breaking equally. This is participating in the what? Bond breaking equally or homolytic fission. It will be takes place. Resulting of that the products what is takes place here? CH2 free radical, at the same time CH2 free radical. CH2 free radical and CH2 free radical, these 2 free radical will be combined. These 2 free radicals of the 2 carbon combined, and resulting space between these 2, a double bond is takes place. That means what is forming here? A alkane is takes place. What is takes place here? Alkane is takes place. Whatever the hydrogen free radical is coming free here, this hydrogen free radical will be react with the CH2 free radical, and the product is CH3. So now what is getting? Alkanes we are getting. So this we call as a disproportionation reaction. This is what we call disproportionation reaction. We call this is the disproportionation reaction. So now when I am taking the free radical mechanism, totally 2 types of mechanisms are takes place. One is free radical mechanism, and one more is what? Ionization mechanism. In the Wurtz reaction, free radical and ionization takes place. If you see the ionization, in that, if you see the free radical, in that association takes place and disproportionation takes place. Whatever the product is forming in the association process, that is major product. Whatever the product is forming in the disproportionation reaction, that is a minor product. So these are the 2 types of products are possible in the ionic, in the free radical mechanism. Once you take the screenshot. And the next one is ionic mechanism. The next one is ionic mechanism. Next one is ionic mechanism. Next one is ionic mechanism. By the ionic mechanism, we can prepare the alkanes. From the alkyl halides, how the alkanes are preparing in the Wurtz reaction will be discussed. So same process, sodium loses 1 electron and converting into sodium plus. Generally 2 atoms of sodium you are taking, so it is released as a 2 electron. It is released as the 2 electron. Now I am taking the ethyl chloride, I am taking C2H5Cl, otherwise you can write as a CH3CH2Cl. Now it is ionic mechanism. Compared to carbon, chlorine is more electronegativity. Due to that, chlorine takes the electron towards itself and will be converted to CH3CH2 plus Cl minus. plus Cl minus. Now here what happened? 2 atoms of sodium is converted to 2 sodium ions by releasing the 2 electron. This 2 electron taken by the carbocation. This 2 electron taken by the ethyl carbocation. Now that ethyl carbocation CH3CH2 plus, it is taking the 2 electrons and converted to CH3CH2 minus. Converted to CH3CH2 minus. Now this CH3CH2 minus we can use for the preparation of the alkane. Let us see here. We taken 2 atoms of sodium, at the same time 2 atoms of 2 molecules of alkyl chloride you have to take. Already 1 molecule of alkyl chloride is completed, another molecule of alkyl chloride I am taking, that is CH3CH2Cl. Same process, chlorine is high electronegativity, takes the electron and converted to CH3CH2 plus Cl minus. Now, if you see these two substances, one is minus charge and one is positive charge, these two substances will be combined and the product is forming CH3CH2 minus plus CH2 plus and CH3 will be combined is give as a butane, and the product formation is butane. So this is the ionic mechanism, and we can say simply this is a nucleophilic substitution reaction. Nucleophilic substitution reaction takes place. So this is the ionic mechanism. So Wurtz reaction, the Wurtz reaction mechanism takes place by the two mechanism again. One is free radical mechanism and another one is ionic mechanism. Generally free radical mechanism is favorable method compared to ionic mechanism, and in the free radical mechanism we will get the major product in the association process. In the dissociation process we cannot get the major product, because in the dissociation process alkenes will be get. So by using the Wurtz reaction we can convert the primary alkyl halide and secondary alkyl halide to alkanes. By using the Wurtz reaction, primary alkyl halides and secondary alkyl halides we can convert it to alkanes, but we cannot convert the tertiary alkyl halides. But we cannot convert the tertiary alkyl halides in the Wurtz reaction, because if we want to convert the tertiary alkyl halides, the product is forming as a alkene. The product is forming as a alkene. So that's why in the Wurtz reaction we are discussing for the preparation of the alkane but not for the alkene. So that's why we cannot use the tertiary alkyl halide for preparation of the alkane in the Wurtz reaction, but you can use the primary alkyl halide and you can use the secondary alkyl halide for preparation of the alkanes. So once you take the screenshot. So next one is Frankland reaction. Next one is Frankland reaction will be discussed. And before that, some examples of the Wurtz reaction. Before that, we will be discuss some examples of the Wurtz reaction. Some examples of the Wurtz reaction will be discussed here. For example, chlorine and for example chlorine. So this is one of the product by using this substance. This is one of the substance in the presence of sodium and dry ether. In the presence of sodium and dry ether, whatever the product is forming, let us see. So generally in the presence of sodium and dry ether, we discussed that free radical mechanism is favorable compared to ionic mechanism. So here this is the carbon and chlorine. Carbon to chlorine, one bond is here, this bond is break equally. At the same time, this is the chlorine, this is the carbon, this bond also breaks equally. Now 2 atoms of sodium will be react with 2 atoms of chlorine, will be converted to 2 molecules of sodium chloride. Then what is the remaining product? Let us see here. This is the product, first carbon and the second carbon and the third carbon and the fourth carbon. So here one free radical present and here one free radical is present. So now if you see that between these two we can write as a one bond. At that time, first carbon, second carbon, third carbon, fourth carbon, fifth carbon. So finally we can write the structure by using the 5 carbons. In this way we can write. So this is the product formation. So this is one of the example, and the second example. And the second example will be discussed here. For example, this is the chlorine and this is the chlorine in the presence of 2 atoms of sodium and in the presence of dry ether as a solvent. So what is the product is possible? Same way, here carbon to chlorine one bond is there. This bond is break equally. At the same time, carbon to chlorine one more bond. This is also break equally. At that time, 2 atoms of sodium and 2 atoms of chlorine will be converted to 2 moles of sodium chloride. And the next product is, let us see, this carbon getting free radical, this carbon also getting free radical. It is one of the free radical, and the another free radical, these 2 free radicals will be combined and form what? Alkene is forming. So in this preparation, what is forming? Alkene is forming in the presence of this one. But generally, Wurtz reaction is favorable for what? Preparation of the alkanes. And in this case, the product is forming what? Alkene. And the next one is, and the next example, same way, another example, chlorine, and here one of the double bond. So same 2 atoms of sodium when I am taking in the presence of dry ether, again the bond is breaking here. So now the product is possible. Now the product is possible. Already 2 bonds is present. One of the electron here, by the combination of this, alkyne is possible. By the combination of this, what is possible? The product is alkyne. So this is the simple examples of the different kind of reactions, different kind of way by using the sodium and dry ether. So next one is a Frankland reaction. Next one is what? Frankland reaction. So what is the Frankland reaction and what will be discussed in the Frankland reaction? So Frankland reaction is the same like a Wurtz reaction. Once again, Frankland reaction is the same like Wurtz reaction, but in the Frankland reaction we are taking the metal atom is zinc, but in the Wurtz reaction we are taking the metal atom is sodium. And one more thing, Wurtz reaction is applicable for primary and secondary alkyl halide, but Frankland reaction is applicable for primary, secondary and tertiary alkyl halide. We can convert the primary alkyl halide, secondary alkyl halide, tertiary alkyl halides to alkane. We can convert the primary alkyl halide, secondary alkyl halide, tertiary alkyl halide to alkane in the presence of or with the help of Frankland reaction. So what is the Frankland reaction? Same like Wurtz reaction, but the metal atom is zinc and in the presence of dry ether. In the presence of dry ether. In the presence of dry ether, and the same product we are getting zinc chloride and alkanes we are getting. Zinc chloride and alkanes we are getting. Same way how we discussed in the Wurtz reaction, 2 different alkyl halides when you take, 3 product mixture is forming. Same way here also a mixture is forming when 2 different alkyl halides we are taking. So this is the Frankland reaction. And the next one is fitting reaction. And the third one is fitting reaction. So chalo, the third one is what here? Fitting reaction. In the fitting reaction, aryl halides couple. In the fitting reaction, aryl halide couple form. Aryl halide couple formation takes place in the presence of sodium metal, at the same time in the presence of dry ether. In the presence of dry ether. So once again, fitting reaction will be take aryl halide, but in the Wurtz reaction, in the fitting reaction will be get a couple of aryl halide. A couple of aryl halide will be get, otherwise will be take a couple of aryl halide. For example, I am taking 2 molecules of aryl halide I am taking. So this is 2 molecules of aryl halide. Same, this reaction is reacting with 2 atoms of sodium in the presence of dry ether, and the product is forming 2 molecules of sodium halide. At the same time, a biphenyl product will be get. So this is a couple of aryl halides when you are taking, the product formation takes place, and this is the fitting reaction. So once again, fitting reaction, a couple of aryl halides when you are taking, the couple of aryl halides react with the 2 atoms of sodium in the presence of dry ether, and the product is forming biphenyl. The product is forming biphenyl. This is the fitting reaction. And the next one is Wurtz fitting reaction. So simply we can say that Wurtz fitting reaction is a combination of Wurtz and fitting reaction. Wurtz fitting reaction is a combination of Wurtz and fitting reaction. So Wurtz fitting reaction. The next one is Wurtz fitting reaction. Simply we can say that Wurtz fitting reaction is a combination of Wurtz and fitting reaction. Wurtz and fitting reaction. Then what is Wurtz reaction? We discussed that. In the Wurtz reaction, we will take the alkyl halide. What will we take? Alkyl halide. In the fitting reaction, will we take the aryl halide? Will we take the aryl halide? So now we are going to discuss about what? Wurtz fitting reaction. So in the Wurtz fitting reaction, alkyl halides will be interact with aryl halides in the presence of sodium and dry ether. So once again, Wurtz fitting reaction. Wurtz reaction nothing but will be take the alkyl halide. Wurtz reaction nothing but will be take the alkyl halide. Fitting reaction nothing but will be take the aryl halide. Will be take the aryl halide. Will be take the aryl halide in the presence of sodium. In the presence of sodium and dry ether. In the presence of sodium and dry ether, 2 molecules of sodium chloride. 2 molecules of sodium chloride is forming. At the same time, this is one of the alkyl group, this is one of the aryl group. Alkyl and aryl group will be combined. And alkyl and aryl group will be combined. So this is Wurtz fitting reaction. For example, if I take the general one is methyl chloride. And methyl chloride react with the 2 atoms of sodium, and the place I am taking one aryl halide. I am taking one aryl halide. So now what happened? These 2 atoms of sodium react with the 2 atoms of chlorine. The product is forming 2 molecules of sodium chloride. The product is forming 2 molecules of sodium chloride. At the same time, it is a methyl group and it is a aromatic group. And finally, by these 2 combination, one of the product takes place, and the product we call as a methyl benzene, or also we call as a toluene. And also what we call toluene. So this is what Wurtz fitting reaction. So once again students, Wurtz fitting reaction is a combination of simply a Wurtz reaction and a fitting reaction. Wurtz reaction nothing but we can take the alkyl halide. Fitting reaction nothing but you can take the aryl halide. So Wurtz fitting nothing but alkyl halide, aryl halide, both we are combining with the help of sodium metal in the presence of dry ether. When I am taking sodium metal will react with halogen groups and converted to sodium halide. The remaining alkyl group and aryl group will be combined and give as a product. So this is a Wurtz fitting reaction. This is a Wurtz fitting reaction. So what we discussed? Wurtz reaction completed, Frankland reaction completed, fitting reaction completed, and Wurtz fitting reaction also completed. And the next reaction we are going to discuss is Uluman synthesis. Next reaction we are going to discuss Uluman synthesis. So Uluman synthesis also same like Uluman synthesis also is the same like fitting reaction. Uluman synthesis. So what is the reaction here? Uluman synthesis. Uluman synthesis is also a same like fitting reaction, but in the fitting reaction we can take the aromatic halide with sodium. Aromatic halide reacting with sodium in the presence of dry ether, but here we are taking aromatic halide. Same aromatic halide I am taking. So maybe this is a iodide I am taking, but I am taking copper. But what I am taking here? Copper. Before that in the reaction we taken the sodium. Now I am taking copper powder. I am taking the copper powder. When I am taking 2 molecules of this aryl halide, now the product is formed, a biphenyl product is formed. So this is a biphenyl product. That means here 2 iodine atoms are present and here 1 copper. So the product again copper iodide takes place. The product what is forming here? Copper iodide takes place, and here biphenyl is forming. This is the Uluman synthesis. Once again, Uluman synthesis same like Frankland reaction, but we are taking instead of the sodium we are taking as a copper powder. So and we are taking aryl halide. I am taking aryl halide when I am taking in the presence of copper powder. So the 2 aryl groups will be combined and will be formed as a biphenyl. This is the Uluman synthesis. So after the Uluman synthesis, the next one is Core-House synthesis. The next one is here. I am taking that Core-House synthesis. The next one is Core-House synthesis. The next one is here Core-House synthesis. So next one is, or the last one is Core-House synthesis. So what is the core house synthesis here? So everything till now what we discussed, Wurtz reaction, and next one Wurtz reaction, and the next one is Frankland reaction, fitting reaction, Wurtz fitting reaction, Uluman synthesis. Everything is preparation of the alkanes only. At the same time, that is core house synthesis also we are using to prepare the alkanes. Here I am taking that one of the alkyl halide, but here this time I am taking the metal lithium. This time what I am taking the metal lithium metal I am taking in the presence of same again dry ether. In the presence of dry ether, now the product is alkyl lithium plus lithium halide. Alkyl lithium plus lithium halide. Once again I am taking the alkyl halide, but instead of the sodium I am taking the lithium in the presence of dry ether. Now this alkyl halide react with lithium will be converting as a alkyl lithium plus lithium halide. Maybe that is chlorine, maybe bromine, maybe iodine, whatever the product we can take. Now here I am taking that. So whatever the alkyl halide is forming, that alkyl halide I am reacting with methyl iodide in the presence of dry ether. Once again here what I am taking, alkyl lithium, alkyl halide what is forming here, whatever the alkyl halide forming, that alkyl halide is reacting with methyl iodide and the product is forming here, methyl. The product is forming here. Let us see here, this is what alkyl halide is, this is a product and it is reacting with the methyl iodide. Now this is one of the methyl group, this is one of the alkyl group. One is what here, methyl group and alkyl group. So just 1 minute, here this is a copper, just 1 minute, here this is a copper. So now this is what here, copper, and this is a alkyl halide. This alkyl halide react with this copper and the product is possible here. This is the product is forming here. I am taking the 2 moles of alkyl halide. 2 moles of alkyl halide I am taking and the product is forming lithium iodide plus this we can say Gilman's reagent. Otherwise we can say Gilman's reagents. So what is the name here? We can say that is a Gilman's reagent. This is the Gilman's reagent we are using in the preparation of the alkane. So in this entire process, whatever the product is forming, Gilman's reagent, this Gilman's reagent, or by using this Gilman reagent, we can prepare the alkanes. So once again you see here, we are discussing about the core house synthesis. In the core house synthesis, I am taking the alkyl halide that I am reacting with lithium. When alkyl halide reacting with lithium in the presence of dry ether, we will get the alkyl lithium, and this alkyl lithium I am reacting with copper iodide. When alkyl lithium react with copper iodide, the product is forming Gilman's reagent and lithium iodide. So whatever the Gilman's reagent is forming, this Gilman's reagent I am using to prepare the alkanes. This Gilman reagent we are using to prepare the what? Alkane. So for example, I am using this Gilman's reagent, copper, lithium, and 2 alkyl groups are there, and I am taking one of the alkyl iodide, otherwise alkyl halide. So for example, I am taking ethyl bromide. I am taking what I am taking here, I am taking the ethyl bromide I am taking. So here bromine is more electronegative, takes the electron towards itself, and at the same time here this is the copper, this is the carbon is more electronegative than compared to copper, and this group is takes the electron. So now the product is what is takes place here, this is converting as a CH3 copper plus lithium, and here this is converting as a CH3 CH2 plus, and here this is a CH3 minus, and one more is bromide ion is possible. Bromide ion is takes place. Now this is a CH2 plus, this is a CH3 minus, this both will be combined. One is CH2 and one more is a CH3. CH2 and CH3, this is the product is forming, this is our alkane. At the same time, this is the copper plus, this is the lithium, and this lithium is metal and it gives an electron to copper. It is going out as a lithium minus. That means CH3 copper will be get, and here this is going out as a lithium plus, and this lithium plus this bromide will be converted to lithium bromide. Will be converted to lithium bromide. So finally what is forming here? In the Uluman synthesis, in the Korehouse synthesis, we can prepare the alkane. So finally we prepare the alkane mainly by using what? By using the Gilman's reagent. So this is the Gilman's reagent. By using the Gilman's reagent, we can prepare the alkane. So once again check here, Korehouse synthesis, I am taking the alkyl halide. Alkyl halides reacting with lithium in the presence of dry ether will be form alkyl lithium, and this alkyl lithium react with copper iodide. This alkyl lithium react with a copper iodide, and the product is forming, this product we call as a Gilman reagent. This Gilman reagent mainly we are using to prepare the alkane. So let us see, this is the Gilman reagent. This Gilman reagent when react with alkyl halide, Gilman reagent when react with the alkyl halide, in this halide is a bromine is more electronegativity, it will be takes the electron and here forming ethyl carbocation. Ethyl carbocation is forming. At the same time here this methyl group takes the electron towards itself and this is converting into methyl carbanion. This methyl carbanion react with ethyl carbocation forming alkane. This is the CH3 minus, it is CH3CH2 plus. The CH3 minus will be react with CH3CH2 plus and converting into propane. And the next one is what here? This copper is getting the positive charge, and to the positive charged copper, lithium giving the electrons, lithium converted to positive charge, and the positive lithium react with bromine and converted to lithium bromide. So this is the entire reaction of the Korehouse synthesis, and finally what you prepared? A alkane is prepared. Finally what you prepared? Alkanes are prepared. So this is the today's session. Once again we discussed here Wurtz reaction and crossed Wurtz reaction, Frankland reaction, next of all what? Fitting reaction and Wurtz fitting reaction, Uluman synthesis and Korehouse synthesis. This every reagent or this every reaction, whatever the reactions we discuss, every reaction we are using to prepare the alkanes. So in the next class we will be discuss the reduction reaction. By using the reduction reactions also we can prepare the alkanes by using the alkyl halide. So this is the session. Thank you.